In this video, we're going to do another integration with partial fractions problem with repeated roots. And this time it's a little more interesting because the denominator has 4 terms, so in order to factor it, we're going to want to use grouping. So if I group them, I can factor out an x squared and get x minus 1. I can factor out a negative 1 and get an x minus 1. That gives me x squared minus 1 and x minus 1. But x squared minus 1 factors as x plus 1, x minus 1. Notice I have another x minus 1, so we get x plus 1, x minus 1 squared. Here's our repeated root. So when we go to set this up, again we'll have a and then one of the repeated roots, and then b, and then the entire repeated root, x minus 1 squared, c, and then the x plus 1. Again, order doesn't matter. And we're going to make common denominators. The a is going to need an x minus 1, and it's going to need an x plus 1. The b has the x minus 1 squared, so it only needs an x plus 1. The c is going to need the repeated root of x minus 1 squared. So now we have a, x minus 1 times x plus 1, plus b times x plus 1, plus c times x minus 1 squared is equal to our original numerator, which is 4x. Let's pick some convenient x values to get some zeros. So looks to me like x is 1 would get us a 0 here. So if I plug in a 1, I get a 0 first term. My second term is 2b. My third term becomes a 0. And my other side becomes 4. So b is 2. That worked well. Now let's choose x is negative 1, because a negative 1 will get me a 0 for my first term. Will get me a 0 for my second term. My third term, negative 1 minus 1 is negative 2 squared would be 4. So I get a 4c is equal to a negative 4. So c equals negative 1. Now let's go ahead and choose another convenient value. I don't have something that'll make a 0, but I can choose 0 for x. If I choose 0 for x, remember I'm plugging in 0 for x, 2 for b, and negative 1 for c. Well, if I plug into my first term, I will get negative a. If I plug into my second term, I will get positive 2. If I plug into my third term, I will get negative 1. And if I plug into the right side, I get 0. So I get negative a is equal to negative 1. Therefore, a is positive 1. I'm now ready to separate the original problem into 3 pieces. My first integral, I can have 1 over x minus 1 dx. My second integral, b value was 2, so I have a 2 over an x minus 1 squared dx. My third integral, I have a negative 1 on top, and on the bottom I would have an x plus 1 dx. Well, now I'm simply integrating these problems separately. My first integral is a natural log absolute value x minus 1. My last integral is also a natural log. We're going to have a negative natural log absolute value x plus 1. Now we've got the middle term. Now let's take a look at that. We could think of that as the integral, push the 2 out in front, x minus 1 to the negative 2 dx. Well, that's a u sub. U is x minus 1. Du is dx, and we have that. So we're really integrating to u to the negative 2 du. Well, u to the negative 2 would be the same as negative 1 over u times 2. So I have negative 2 over x minus 1. So my final answer, if I take this and I substitute in, I would have my negative 2 over x minus 1. And don't forget your plus c.